Chapter 2 Linear Correlations 1. Introduction. So far, our study was restricted to the distribution of one variable. But many situations arise in which it is desirable and necessary to study two or more variables at a time. Example, if we study the yearly sale of a product of a company, we would also like to know its profit, as from that we can find the nature and degree of relation between these two variables, sale of product and profit. The yearly rainfall and yield of rice in some region, price and demand for an item, income and expenditure of a family, height of father and height of his son, age of husband and age of wife, etc. are some well-known examples where we see the relation between paired variables. Similarly, we come across many situations in which two variables are related. Note: a distribution is said to be univariate distribution if it is obtained by collecting the information of one variable. Example, the distribution of marks obtained by students in a subject, monthly income of persons working in a company, age of drivers of state transport, that is ST buses. The information obtained for two different characteristics of a unit at the same time is called bivariate data, and the distribution obtained from it is known as bivariate distribution. Example, the distribution of price and supply of an item, monthly expenditure and saving of families of a group, age of husband and age of wife. The simultaneous changes in the values of more than two variables can be studied by multiple and partial correlation, but here we shall study correlation between only two variables. 2. Meaning and definition of linear correlation. Let us first understand the meaning of correlation. We know that in many situations, simultaneously changes are seen in the values of two variables. The simultaneously changes in the values of two variables are mainly due to: Number 1. There is a cause-effect relation between two variables. Number 2. The values of two variables change due to the effect of some other factor. In case of yearly rainfall and yield of rice of a region, usually if rainfall increases, that is up to some extent, yield of rice also increases, and if rainfall decreases, yield of rice also decreases. So, rainfall is a cause and yield of a rice is an effect. Similarly, when the income of a person remains more or less same, if his expenditure increases, saving decreases, and if his expenditure decreases, saving increases. Expenditure is a cause here and saving is the effect. The changes in two variables in the above two examples indicate cause-effect relationship. Sometimes both the variables may be mutually dependent and therefore neither can be specifically said as the cause and the other the effect. Generally, it happens in case of economic variables. Example, demand and supply. If demand increases, it is necessary to increase supply, that is, which is not always possible instantly. And when supply increases, price tends to decrease, and because of that demand goes up. Thus, demand and supply are interdependent. The ages of husband and age of wife is also an example of such situation. In case of sale of raincoats and sale of rain shoes, the values of both the variables increase in monsoon. There is no direct cause-effect relation here between two variables, but the changes in the sale of raincoats and rain shoes are observed due to the presence of the third variable, namely the monsoon. This is an example of indirect cause-effect relationship. If there are simultaneously changes in the values of two variables due to direct or indirect cause-effect, then it is said that there is correlation between two variables. The correlation is said to be linear correlation. If the points plotted on the graph paper corresponding to order pairs of the values of two correlated variables are on a line or nearer to the line. In other words, when the changes in the values of two correlated variables have nearly constant proportion, then we can say that there is linear correlation. Generally, exact linear relation exists in natural sciences like mathematics and physics. That is, because of change in one variable, the value of other variable changes in constant proportion. Example 1. Radius and circumference. We know that if the radius of a circle is r units, then its circumference is 2 pi r. So, when radius is multiplied by 2 pi, that is constant, we get its circumference. Thus, it can be said that because of change in radius, the circumference of the circle changes in constant proportion. This is clear from the following table. Radius r, circumference 2 pi r, 2, 4 pi, 3, 6 pi, 5, 10 pi, 10, 20 pi. 2. At a constant speed, time taken by an object to travel the distance and the distance travelled by an object. If an object is travelling at the speed of 50 km per hour, then the distance travelled is in constant proportion to the time taken to travel it. We can understand it very easily from the following table. Time taken by an objective to travel, hours. Distance travelled by an object, kilometer. 2, 100. 3, 150. 6, 300. 10, 500. But generally, in commerce, economics and social science, the changes in the values of two variables are not in constant proportion. Example, if rainfall in the current year increased by 10% for 2 consecutive years as compared to the previous year, then it is not necessary that yield also increases in same proportion for both the years. This is because variables rainfall and yield change under the effect of some other factors, and hence there is an element of change, that is uncertainty, in these changes. So, in such cases, the points of ordered pairs of two correlated variables may not be on the line, but they may be almost nearer to the line. There are mainly two types of correlation. Number 1, positive correlation. Number 2, negative correlation. Number 1, positive correlation. When the changes in the values of two correlated variables are in the same direction, the correlation between them is said to be positive. The correlation between price and supply of an item, age of husband and age of wife, number of vehicles and number of accidents on a road, sale and profit of an item, rainfall and yield of crop in a region are some examples of positive correlation. Number 2, negative correlation. When the changes in the values of two correlated variables are in opposite direction, the correlation between them is said to be negative. The correlation between price and demand of an item, expenditure and saving of a person, minimum day temperature, and sale of woolen clothes in winter, altitude and amount of oxygen in air are some examples of negative correlation. 3. Correlation and coefficient of correlation. The measure of the strength of a linear correlation between two variables is called the correlation coefficient. It is denoted by R. The correlation coefficient is a numerical measure of correlation which shows the strength or degree of linear correlation between two correlated variables. This measure was first suggested by Karl Pearson. Method of study correlation. The following methods are mainly used to determine the nature and strength of correlation between two variables. 1. Scatter diagram method. 2. Karl Pearson's product movement method. 3. Spearman's rank correlation method. 4. Scatter diagram method. This is a simple method of diagrammatic representation of two related variables to find the nature of correlation. This is the most widely used method for determining the nature of correlation. Moreover, it also gives some idea about the strength of correlation between two variables. Suppose x1, y1, x2, y2, x3, y3, up to xn, yn are ordered pairs of n values of two variables x and y. The values of variable x on x-axis and the values of variable y on y-axis are plotted on the graph by taking proper scale. The graph showing the plotted points corresponding to pairs x1, y1, x2, y2, x3, y3 up to xn, yn is called a scatter diagram. The pattern of points on a scatter diagram shows the nature or type of correlation and the strength of correlation up to some extent. Now, let us see how the nature and strength of correlation between two variables can be determined by using scatter diagram. If all the points of scatter diagram lie on one line and if the line is going in the upward direction from left to right, then it shows perfect positive correlation between two variables x and y. We get such a scatter diagram when the changes in the values of two variables are in the same direction and in the constant proportion. Illustration. After standard deduction from total income, 20% income tax is imposed on the remaining income. The information regarding the taxable income and the tax to be paid is given below for 5 persons. Person 1, 2, 3, 4, 5. Tax income in 1000 x. Income tax in 1000 y. 50, 10, 30, 6, 80, 16, 20, 4, 100, 20. Draw a scatter diagram for this information and discuss about the correlation. Answer. The following scatter diagram is obtained by plotting the points corresponding to the ordered pairs 50, 10, 30, 6, 80, 16, 20, 4 and 100, 20 of x and y. We can see that all the points lie on the same line in the scatter diagram. We can also see that as the values of variable x change, the value of variable y also change in the same direction with a constant proportion. Check that when the values of variable x is multiplied by 0.2, that is 20%, the corresponding value of variable y of the ordered pair is obtained. So the changes in the two variables x and y are in same proportion. Hence, we can say that there is a perfect positive correlation between two variables x and y. Illustration 1. A ball pen making company wants to know the relation between the price in percentage and supply in 1000 units of its most selling gel pen. The following information is collected for it. Draw a scatter diagram and interpret it. Price in rupees. Monthly supply in 1000 units. 14, 32, 16, 50, 12, 20, 11, 12, 15, 45, 13, 30, 17, 53. Answer. The following scatter diagram is obtained by plotting the points corresponding to the order pairs 14, 32, 16, 50, 12, 20, 11, 12, 15, 45, 13, 30 and 17, 53 of x and y. We can see that all the points lie on the different line in the scatter diagram. We can also see that as the values of variable x change, the values of variable y also change in the different direction with a constant proportion. Hence, we can say that there is a partial positive correlation between two variables x and y. Illustration 2. A company manufactures ready-made garments. The monthly advertisement cost in 10 lakh rupees and the sale of garments in crore rupees for the last 6 months are given below. Advertisement cost 10 lakh rupees X. Sale of garments crore rupees Y. 5, 20, 8, 30, 10, 50, 15, 70, 12, 60, 9, 35. Draw a scatter diagram from the data and discuss about the correlation. Answer. The following scatter diagram is obtained by plotting the points of ordered pairs 5, 20, 8, 30, 10, 50, 15, 70, 12, 60 and 9, 35 of two variables x and y on the graph paper. We can see that all points on the scatter diagram do not lie on the same line. The changes in advertisement cost and sales are in the same direction but not in the same proportion. Hence, all the points are not on the same line. So, we can say that there is a partial positive correlation between x and y. Illustration 3. A company manufactures RO plants for the factories. The information about the advertisement, cost for its sales, and the profit from the sale of RO plants is given below. Advertisement cost 10,000 rupees. Profit in lakh rupees. 5, 8, 6, 7, 7, 9, 8, 10, 9, 13, 10, 12, 11, 13. Draw a scatter diagram for this information and state the nature of the relationship between the advertisement cost and profit earned from the sale of RO plants. Answer. The following scatter diagram is obtained by plotting the points of order pairs 5, 8, 6, 7, 7, 9, 8, 10, 9, 13, 10, 12 and 24, 8 of two variables x and y on the graph paper. Analysis. We can see that all the points do not lie on the same line in the scatter diagram. The advertisement cost and profit are in opposite direction, but they do not change in same proportion. Hence, all points are not on the same line. So, we can say that there is a partial positive correlation between x and y. Merits and limitations of scatter diagram method. Merits. 1. This is a simple method to know the nature of correlation between two variables. 2. Less mathematical knowledge is required as the knowledge of plotting the points is only the requirement in this method. 3. It also gives some idea about strength of correlation between two variables. 4. The scatteredness of the points suggests whether the correlation is linear or not. 5. There is no difficulty in judging the nature of correlation even if some pairs of extreme observations are present in the data. Limitation. This method gives nature of correlation and some idea about strength of correlation, but it does not give exact degree of relationship between two variables. 5. Karl Pearson's product movement method. The numerical measure of correlation which shows strength of correlation between two variables is known as correlation coefficient. Since this correlation coefficient was first suggested by statistician Karl Pearson, it is also known as Pearson's correlation coefficient or product movement coefficient. It is denoted by R. Let n pairs of observations of a sample on two variables x and y be x1, y1, x2, y2, up to xn, yn. The coefficient of correlation between variables x and y is denoted by R, x, y or simply R, and it can be obtained as follows. R is equal to covariance xy divided by sx sy is equal to covariation xy divided by standard deviation of x into standard deviation of y, where covariation xy is equal to covariation xy is equal to sigma xi minus x bar into yi minus y bar divided by n. Standard deviation of x is equal to sx is equal to under root sigma xi minus x bar whole square divided by n. Standard deviation of y is equal to sy is equal to under root sigma yi minus y bar whole square divided by n. Mean of x is equal to x bar is equal to sigma xi divided by n. Mean of y is equal to y bar is equal to sigma yi divided by n. Note, for simplicity, the suffix I is ignored in all subsequent formula in the study of linear correlation and linear regression, and x is replaced by x and y is replaced by y in the formula and the calculations. By substituting these values of covariation xy, sx and sy in the above formula of R, we get the following form of R. R is equal to sigma x minus x bar into y minus y bar divided by under root sigma x minus x bar whole square into under root sigma y minus y bar whole square. Generally, the above formula of R is used when both the means x bar and y bar are integers. Now, the following are alternative formula for covariation xy, sx and sy. Covariation xy is equal to sigma xy minus n x bar y bar divided by n. Sx is equal to under root sigma x square divided by n minus x bar square. Sy is equal to under root sigma y square divided by n minus y bar square. The following are some other forms of formula of correlation coefficient R. When the measures like sigma x minus x bar into y minus y bar, standard deviation of x, standard deviation of y and n are known, we can use the following formula of R. R is equal to sigma x minus x bar into y minus y bar divided by n into sx into sy. When the measures like sigma xy means x bar and y bar, standard deviation of x and y and n are known, we can use the following formula of R. R is equal to sigma xy minus n x bar y bar divided by n into sx into sy. When the measures like sigma x, sigma y, sigma xy, sigma x square, sigma y square and n are known, we can use the following formula of R. R is equal to n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square. Generally, the above formula of R is used when mean x bar or y bar both are fractional. Assumptions of Karl Pearson correlation coefficient. Karl Pearson's correlation coefficient is based on the following assumptions. Number 1. There is a linear relation between two variables. Number 2. There is a cause-effect relationship between two variables. Correlation is meaningless if there is no such relationship. 6. Properties of correlation coefficient. Number 1. The value of the correlation coefficient lies in the interval -1 to 1, that is -1 less than equals to r less than equals to 1. Number 2. The correlation coefficient is free from unit of measurement. Whatever may be the units of two variables, r does not have any unit of measurement. Number 3. The correlation coefficient between variables x, y and y is same as the one of between y and x, that is r xy is equal to r yx. Number 4. The correlation coefficient does not change with the change, that is transformation of origin and scale. Explanation. Suppose the correlation coefficient r is to be obtained between variables x and y. Now, first we define the new transformed variables u and v as follows. U is equal to x minus a divided by cx and v is equal to y minus b divided by cy, where a, b, cx, cy are suitable real constants and Cx greater than 0 and Cy greater than 0. Now, this property of R implies that the correlation coefficient between u and v and the one between x and y are equal, that is R uv is equal to R xy is equal to R. Number 5. R minus xy is equal to minus R xy. R x minus y is equal to minus R xy. That is, if the sign of any one of the two variables x and y is changed, then the sign of the correlation coefficient also changes. R minus x minus y is equal to R xy. That is, if the signs of both the variables are changed, then the sign of the correlation coefficient remain unchanged. 7. Interpretation of the value of correlation coefficient. We know that the correlation coefficient shows the type, that is nature, and the extent or state of the relationship between two variables. It is necessary to interpret the value of the correlation coefficient after obtaining it. The type of correlation can be known by the sign of the correlation coefficient, and its strength can be known by its numerical value. While interpreting the value of R, we should keep in mind that R denotes the type and strength of linear relation between two variables, and it does not indicate the cause-effect relationship between them. In fact, we have tacitly assumed the cause-effect or any other type of relation between them. The value of R does not necessarily indicate the cause-effect relationship between two variables. In view of this fact, we shall now see how the value of R can be interpreted. Interpretation of R is equal to 1. If R is equal to 1, then we can say that there is a perfect positive correlation between two variables when increase or decrease in the value of one variable result in increase or decrease in the value of the other variable in constant proportion, then the value of R is 1. For such variables, we get all points on the same straight line in increasing direction in the scatter diagram. Interpretation of R is equal to minus 1. If R is equal to minus 1, then we can say that there is a perfect negative correlation between two variables when increase or decrease in the value of one variable result in decrease or increase in the value of the other variable in constant proportion, then the value of R is minus 1. For such variables, we get all points on the same straight line in decreasing direction in the scatter diagram. Interpretation of R is equal to 0. If R is equal to 0, then we can say that there is no linear correlation between two variables. In other words, R is equal to 0 shows absence of correlation, and hence two variables are said to be linearly uncorrelated. For such variables, we get randomly scattered points, that is, not on or around any line in the scatter diagram. Note that the numerical value of R gives only the state of linear correlation. So when R is equal to 0, we can only say that linear correlation between two variables is absent, but there may be non-linear correlation. From the scatteredness of the points in the scatter diagram, we can get some idea about the type of non-linear correlation. Interpretation of partial correlation. Interpretation of R less than 1 and minus 1 less than R less than 0. If the value of R is between 0 and 1 or between minus 1 and 0, that is, if modules are less than 1, then we can say that there is a partial, that is, imperfect correlation between two variables. When the value of modules R is nearer to 1, we can say that the relationship between two variables is close to perfect linear correlation and there is high degree of the relationship. In such a case, we can obtain a reliable estimate of changes in one variable corresponding to changes in value of the other variable. When the value of modules R is nearer to 0, we can say that straight of the linear relation is very less and there is almost lack of linear correlation between two variables. In such a case, we cannot obtain a reliable estimate of the changes in the value of one variable corresponding to changes in the value of the other variable. Interpretation of R: -1, low degree 0, high degree 1, perfect negative correlation, lack of linear correlation, perfect positive correlation. Illustration 4. From the following information obtained from a sample of 7 families of a society regarding height of father in centimeters and height of his adult son in centimeters, calculate the correlation coefficient. Height of father in centimeter, height of son in centimeter, 170, 172, 169, 168, 168, 170, 167, 168, 166, 165, 165, 167, 164, 166. Answer. Here n is equal to 7, x is equal to height of father and y is equal to height of son. Now x bar is equal to sigma x divided by n is equal to 1169 divided by 7 is equal to 167 and y bar is equal to sigma y divided by n is equal to 1176 divided by 7 is equal to 168. Since the means x bar and y bar are fractional, we can compute R as follows. Height of father in centimeter x, height of son in centimeter y, x minus x bar is equal to 167, y minus y bar is equal to 168, x minus x bar into y minus y bar, x minus x bar whole square, y minus y bar whole square, 170, 172, 3, 4, 12, 9, 16, 169, 168, 2, 0, 0, 4, 0, 168, 170, 1, 2, 2, 1, 4, 167, 168, 0, 0, 0, 0, 0, 166, 165, -1, -3, 3, 1, 9, 165, 167, -2, -1, 2, 4, 1, 164, 166, -3, -2, 6, 9, 4. Total sigma x is equal to 1169. Sigma y is equal to 1176. Sigma x minus x bar is equal to 0. Sigma y minus y bar is equal to 0. Sigma x minus x bar into y minus y bar is equal to 25. Sigma x minus x bar whole square is equal to 28. Sigma y minus y bar whole square is equal to 34. R is equal to sigma x minus x bar into y minus y bar divided by under root sigma x minus x bar whole square into under root sigma y minus y bar whole square. Here sigma x minus x bar into y minus y bar is equal to 25. Sigma x minus x bar whole square is equal to 28 and y minus y bar whole square is equal to 34. R is equal to 25 divided by under root 28 into under root 34 is equal to 25 divided by under root 952 is equal to 25 divided by 30.85 is equal to 0.81. We can see that the value of R is close to 1. Thus, there is a high degree of positive correlation between height of father and the height of son. Illustration 5. The details of monthly sale of mobile phones in 1000 units and its profit in lakh rupees for the last 6 months for a company making mobile phones are given below. Number of mobile phones sold 1000 units X. Profit lakh rupees Y. 3, 6, 8, 10, 12, 15, 5, 10, 7, 9, 5, 8. Find the correlation coefficient between number of mobile phones sold and its profit. Answer. Here n is equal to 6, x bar is equal to sigma x divided by n is equal to 40 divided by 6 is equal to 6.67. Y bar is equal to sigma y divided by n is equal to 58 divided by 6 is equal to 9.67. Since the means x bar and y bar are fractional and the values of x and y are not very large, we can compute R as follows. Number of mobile phones sold 1000 units X. Profit lakh rupees Y. XY X square Y square. 3, 6, 18, 9, 36, 8, 10, 80, 64, 100, 12, 15, 180, 144, 225, 5, 10, 50, 25, 100, 7, 9, 63, 49, 81, 5, 8, 40, 25, 64. Total 40, 58, 431, 316, 606. R is equal to n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square is equal to 6 into 431 minus 40 into 58 divided by under root 6 into 316 minus 40 square into under root 6 into 606 minus 58 square is equal to 2586 minus 2320 divided by under root 1896 minus 1600 into under root 3636 minus 3364 is equal to 266 divided by under root 296 into under root 272 is equal to 266 divided by under root 80,512 is equal to 266 divided by 283.7464 is equal to 0.9375. Therefore, R equals to 0.94. We can see that the value of R is close to 1. Thus, there is a high degree of positive correlation between sale of mobile phones and its profit. Illustration 6. To check the ability of mathematics and logic of the students of a city, a private educational institution gives 20 puzzles based on these two subjects to 6 children selected from various schools. The number of puzzles solved by them is given below. Number of puzzles solved based on mathematics. Number of puzzles solved based on logic. 12, 11, 8, 10, 9, 4, 10, 7, 8, 13, 11, 16. Compute the correlation coefficient between performance of children in two types of puzzles using the given data. Answer. Here n is equal to 6, x is equal to number of puzzles solved based on mathematics and y is equal to number of puzzles solved based on logic. Now x bar is equal to sigma x divided by n is equal to 58 divided by 6 is equal to 9.67. Y bar is equal to sigma y divided by n is equal to 61 divided by 6 is equal to 10.17. Since both the means x bar and y bar are fractional and the values of the variables x and y are not very large, we can compute R as follows. X, y, xy, x square, y square, 12, 11, 132, 144, 121, 8, 10, 80, 64, 100, 9, 4, 36, 81, 16, 10, 7, 70, 100, 49, 8, 13, 104, 64, 169, 11, 16, 176, 121, 256. Total sigma x is equal to 58, sigma y is equal to 61, sigma xy is equal to 598, sigma x square is equal to 574, sigma y square is equal to 711. Coefficient r is equal to n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square. Here n is equal to 6, sigma xy is equal to 598, sigma x is equal to 58, sigma y is equal to 61, sigma x square is equal to 574 and sigma y square is equal to 711 is equal to 6 into 598 minus 58 into 61 divided by under root 6 into 574 minus 58 square into under root 6 into 711 minus 61 square is equal to 3588 minus 3538 divided by under root 3444 minus 3364 into under root 4266 minus 3721 is equal to 50 divided by under root 80 into under root 545 is equal to 50 divided by under root 43600 is equal to 50 divided by 208.81. Therefore, R equals to 0.24. Hence, the correlation coefficient between performances of children in two types of puzzles obtained 0.24. We have seen that both means x and y were not integers and the values of x and y were not very large, and hence we have used the following formula to compute the value of R. R is equal to n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square. But when the values of two variables are numerically large and or fractional, the computation of x and y becomes more difficult and hence the calculation of becomes tedious. So, in order to make the computation of R simple, a shortcut method is used. This shortcut method is based on the property number 4 of R. According to this property, replacing x by u and y by v in the formula of R, we get the following formula of R by shortcut method. R is equal to n sigma uv minus sigma u into sigma v divided by under root n sigma u square minus sigma u whole square into under root n sigma v square minus sigma v whole square. Illustration 7. To know the relation between the heights and weights of the students of a school, a sample of 6 students is taken and the following information is obtained. Find the correlation coefficient between the heights and weights of the students. Height in centimeter x, weight in kilogram y. 155, 53, 165, 63, 158, 56, 162, 60, 153, 52, 160, 60. Here n is equal to 6, x bar is equal to sigma x divided by n is equal to 953 divided by 6 is equal to 158.83. Y bar is equal to sigma y divided by n is equal to 344 divided by 6 is equal to 57.33. Since both the means x bar and y bar are fractional and the values of the variables x and y are large, we shall prefer the shortcut method for the computation of r. We take a is equal to 158 and b is equal to 57 to change the origin, and since there are no suitable values for change of scale, we take cx is equal to 1, cy is equal to 1. We shall define new variables u and v as follows. U is equal to x minus a divided by cx is equal to x minus 158 divided by 1 is equal to x minus 158, and v is equal to y minus b divided by cy is equal to y minus 57 divided by 1 is equal to y minus 57. U is equal to x minus a is equal to x minus 158. V is equal to y minus b is equal to y minus 57. Height in centimeter x, weight in kilogram y. U is equal to x minus 158. V is equal to y minus 57. UV, u square, v square. 155, 53, minus 3, minus 4, 12, 9, 16. 165, 63, 7, 6, 42, 49, 36. 158, 56, 0, minus 1, 0, 0, 1. 162, 60, 4, 3, 12, 16, 9. 153, 52, minus 5, 25, 25, 25. 160, 60, 2, 3, 6, 4, 9. Total 953, 344, 5, 2, 97, 103, 96. R is equal to n sigma uv minus sigma u into sigma v divided by under root n sigma u square minus sigma u whole square into under root n sigma v square minus sigma v whole square is equal to 6 into 97 minus 5 into 2 divided by under root 6 into 103 minus 5 square into under root 6 into 96 minus 2 square is equal to 582 minus 10 divided by under root 618 minus 25 into under root 576 minus 4 is equal to 572 divided by under root 593 into under root 572 is equal to 572 divided by under root 3,39,196 is equal to 572 divided by 582.4054 is equal to 0.9821. Therefore, R equals to 0.98. We can see that the value of R is very close to 1. Thus, there is a high degree of positive correlation between the height and the weight of the students. Illustration 8. To study the relationship between the marks obtained in statistics X and marks in economics Y of the students of a school, a sample of 10 students is taken and the following information is obtained. Sigma x minus x bar into y minus y bar is equal to 120. Sigma x minus x bar whole square is equal to 80. Sigma y minus y bar whole square is equal to 500. Find the value of R. Here n is equal to 10 and the following formula is suitable to the given data. R is equal to sigma x minus x bar into y minus y bar divided by under root sigma x minus x bar whole square into under root sigma y minus y bar whole square is equal to 120 divided by under root 80 into under root 500 is equal to 120 divided by under root 40,000 is equal to 120 divided by 200. Therefore, R is equal to 0.6. Illustration 9. Find the value of R from the following data. 1. N is equal to 20. Covariation xy is equal to minus 50. Sx is equal to 15. Sy is equal to 8. 2. N is equal to 10. Sigma x minus x bar into y minus y bar is equal to 60. Variance of x is equal to 25. Variance of y is equal to 36. Particulars: x, y. Number of observations 25. Mean 40, 50. The sum of squares of deviations taken from mean 120, 160. The sum of product of deviations taken from mean 100. 4. N is equal to 10. Sigma xy is equal to 1500. Mean of x is equal to 12. Mean of y is equal to 15. Standard deviation of x is equal to 9. Standard deviation of y is equal to 5. Number 1. Here n is equal to 20. Covariance xy is equal to minus 50. Sx is equal to 15. Sy is equal to 8. Substituting these values in the following formula. R is equal to covariance xy divided by Sx into Sy is equal to minus 50 divided by 15 into 8 is equal to minus 50 divided by 120 is equal to minus 0.4167. Therefore, R is equal to minus 0.42. Number 2. Here n is equal to 10. Sigma x minus x bar into y minus y bar is equal to 60. Variance of x is equal to Sx square is equal to 25. Therefore, Sx is equal to 5. Variance of y is equal to Sy square is equal to 36. Therefore, Sy is equal to 6. Substituting the required values in the following suitable formula. R is equal to sigma x minus x bar into y minus y bar divided by n into Sx into Sy is equal to 60 divided by 10 into 5 into 6 is equal to 60 divided by 300. Therefore, R is equal to 0.2. Number 3. Here n is equal to 25, x bar is equal to 40, y bar is equal to 50. Sigma x minus x bar whole square is equal to 120. Sigma y minus y bar whole square is equal to 160. And sigma x minus x bar into y minus y bar is equal to 100. Substituting all these values in the following suitable formula. R is equal to sigma x minus x bar into y minus y bar divided by under root sigma x minus x bar whole square into under root sigma y minus y bar whole square is equal to 100 divided by under root 120 into under root 160 is equal to 100 divided by under root 19,200 is equal to 100 divided by 138.5641 is equal to 0.7212. R is equal to 0.72. Number 4. Here n is equal to 10, sigma xy is equal to 1500, x bar is equal to 12, y bar is equal to 15, sx is equal to 9 and sy is equal to 5. Substituting all these values in the following suitable formula. R is equal to sigma xy minus n x bar y bar divided by n into sx into sy is equal to 1500 minus 10 into 12 into 15 divided by 10 into 9 into 5 is equal to 1500 minus 1800 divided by 450 is equal to minus 300 divided by 450 is equal to minus 0.6667. Therefore, R is equal to minus 0.67. Illustration 10. To To study the relationship between the sales and the profit of a company, the following information is obtained for the last 6 years. X is equal to annual sales lakh rupees. Y is equal to annual profit 10,000. N is equal to 6. Sigma xy is equal to 431. Sigma x is equal to 58. Sigma y is equal to 61. Sigma x square is equal to 606. And sigma y square is equal to 316. Find the correlation coefficient between x and y. Substituting the given values in the following formula. R is equal to n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square is equal to 6 into 431 minus 58 into 40 divided by under root 6 into 606 minus 58 square into under root 6 into 316 minus 40 square is equal to 2586 minus 2320 divided by under root 3636 minus 3364 into under root 1896 minus 1600 is equal to 266 divided by under root 272 into under root 296 is equal to 266 divided by under root 80,512 is equal to 266 divided by 283.7464 is equal to 0.9375. Therefore, R equals to 0.94. Illustration 11. Find the value of R from the following data. Particulars X, Y. Average 60, 95. The sum of squares of deviations taken from their mean 920, 1050. The sum of product of deviations taken from their mean minus 545. Here x bar is equal to 60, y bar is equal to 95, sigma x minus x bar whole square is equal to 920, sigma y minus y bar whole square is equal to 1050 and sigma x minus x bar into y minus y bar is equal to minus 545. Now R is equal to sigma x minus x bar into y minus y bar divided by under root sigma x minus x bar whole square into under root sigma y minus y bar whole square is equal to minus 545 divided by under root 920 into under root 1050 is equal to minus 545 divided by under root 9,66,000 is equal to minus 545 divided by 982.85 is equal to minus 0.55. Hence, the correlation coefficient obtained is minus 0.55. Merits and limitations of Karl Pearson's method. Merits. 1. The type, that is nature as well as the degree of relationship between two variables, can be known by this method. 2. This is the most popular method of measuring linear correlation between two variables. 3. It summarizes the degree, that is high, moderate or low, of correlation in a single number. Limitations. 1. It depends on the assumption that two variables under consideration have linear relationship. So, if it is used in spite of not having linear relationship between two variables, then the interpretation based on it will be misleading. 2. The value of correlation coefficient is highly affected by the extreme, that is too large or too small observations. 3. Utmost care is required to interpret this coefficient, otherwise the relationship between two variables may be misunderstood. 8. Spearman's rank correlation method. We have studied the Karl Pearson's method to find the correlation coefficient between two variables. It is clear that this method is used when two variables are quantitative, that is, both the variables are numerically measurable. But in problems of business, industry, and social science, there are some situations when we deal with qualitative variable, that is, attribute, example, beauty, honesty, skill, morality, proficiency in elocution, music, dance, etc. In such situations, these characteristics, that is, qualitative variable or attributes, are incapable of quantitative measurement, but they can be serially according to their proficiency in such characteristics. The correlation coefficient computed using such ranks of two characteristics, that is, qualitative variable, as suggested by Charles Spearman, is known as Spearman's rank correlation coefficient. Some of the examples in which the Spearman's rank correlation coefficient is to be obtained to know the relationship are as follows. 1. The study of the relationship between two attributes, honesty and punctuality, for a group of persons by ranking them according to their proficiency. 2. The study of the relationship between the judgments of two judges in a beauty contest who rank the contestants according to their performance in their contest. Sometimes, even if the data consist of quantitative variables like height, weight, the rank correlation coefficient is obtained by assigning the ranks to the numerical observations according to their magnitudes. Generally, when there is more dispersion among the values of the observations of two variables, rank correlation coefficient is preferred over Karl Pearson's correlation coefficient because rank correlation coefficient is more stable about dispersion of the observations as compared to Karl Pearson's correlation coefficient. Method. Suppose the ranks for n pairs of observation of two attributes x and y are assigned as follows. Serial number of observation 1, 2, up to I, up to n. Rank based on x, rx1, rx2, up to rxi, up to rxn. Rank based on y, ry1, ry2, up to ryi, up to ryn. The following formula is used to find the rank correlation coefficient. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1, where di is equal to rxi minus ryi, rxi minus ryi, I is equal to 1, 2, 3 up to n. For the sake of convenience, we shall write d in place of di, rx in place of rxi and ry in place of ryi. So the formula for rank correlation coefficient can be written as follows. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1, where d is equal to rx minus ry is equal to difference between the ranks of x and y. Sigma d square is equal to the sum of squares of difference in the ranks of x and y. When n pairs of observations are numerical measurements, that is, quantitative variables, generally the highest observation is given the rank 1, the second highest observation is given rank 2, and so on for each variable, and the rank correlation coefficient can be obtained from these ranks. Although we use rank correlation coefficient to find the relationship between two quantitative variables, Karl Pearson's correlation coefficient is more effective as actual observations are used in the calculations and not the ranks. Note that the Spearman's correlation coefficient is nothing but Karl Pearson's correlation coefficient between the ranks of two attributes, that is, variables. Therefore, it can be interpreted in the same way as we interpret the Karl Pearson's correlation coefficient. Generally, the values of the Spearman's rank correlation coefficient and Karl Pearson's correlation coefficient are not equal. But when the values of two variables are some arrangement of first and natural number, the correlation coefficients obtained by Karl Pearson's method and Spearman's method are equal. Illustration 12. 7 employees are selected from a company. They are judged by 2 managers from the company in terms of their administrative skills. The ranks given by them are as follows. Employee, rank by manager 1, rank by manager 2, A 6, 7, B 7, 6, C 5, 5, D 4, 2, E 3, 4, F 2, 1, G 1, 3. Calculate the rank correlation coefficient between the judgments given by 2 managers. Here n is equal to 7 and the ranks are already given. So, we prepare the following table to compute the rank correlation coefficient. Worker, rank by manager 1, Rx, rank by manager 2, Ry. D is equal to Rx minus Ry. D square. A 6, 7, minus 1, 1. B 7, 6, 1, 1. C 5, 5, 0, 0. D 4, 2, 2, 4. E 3, 4, minus 1, 1. F 2, 1, 1, 1. G 1, 3, minus 2, 4. Total 0, 12. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1 is equal to 1 minus 6 into 12 divided by 7 into 49 minus 1 is equal to 1 minus 72 divided by 336 is equal to 1 minus 0.2143 is equal to 0.7857. The value of R is near to 1, that is, it shows partial positive correlation. So, it can be said that there is a similarity between the ranks of the employee given by 2 managers. Illustration 13. The principal of a school has conducted a test for 5 students selected in a sample to judge the relation between the knowledge of mathematics and memory ability in the subject of history of the students. The ranks given to these 5 students in the subjects of mathematics and history are given below. Find the rank correlation coefficient between ranks of 2 subjects using this information. Student, rank in mathematics, rank in history. A 2, 4, B 5, 1, C 1, 5, D 4, 2, E 3, 3. Here n is equal to 5 and the ranks are already given. So, we prepare the following table to compute the rank correlation coefficient. Student, Rx, Ry, D is equal to Rx minus Ry, D square. A 2, 4, minus 2, 4. B 5, 1, 4, 16. C 1, 5, minus 4, 16. D 4, 2, 2, 4. E 3, 3, 0, 0. Total 0, 40. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1 is equal to 1 minus 6 into 40 divided by 5 into 25 minus 1 is equal to 1 minus 240 divided by 120 is equal to 1 minus 2 is equal to minus 1. Since the performance of 5 students in mathematics and history are exactly in opposite order, we get R is equal to minus 1. Illustration 14. To know the relationship between the abilities of the students of a school in the subjects of statistics and accountancy. The teachers of both the subjects have taken a sample of 8 students and the following information was collected. Student, marks in statistics, X, Marks in accountancy Y 1 78 84 2 36 51 3 98 91 4 25 60 5 75 68 6 82 62 7 90 86 8 62 55. Calculate the rank correlation coefficient between the marks of statistics and the marks of accountancy. Answer. Here n is equal to 8. We are given quantitative variables, that is marks in two subjects. So first we have to assign the ranks according to the marks obtained by the students in two subjects. In statistics, a student with roll number 3 gets the highest marks 98 and hence is ranked 1. Roll number 7 gets 90 marks, that is second highest, and hence is ranked 2, and so on. Similarly, we can assign the ranks to the students based on their marks in the subject of accountancy. Let us prepare a table as follows. Roll number, statistics, marks, rank RX, accountancy, marks, rank RY. D is equal to RX minus RY. D square 1 78 4 84 3 1 1 2 36 7 51 8 minus 1 1 3 98 1 91 1 0 0 4 25 8 60 6 2 4 5 75 5 68 4 1 1 6 82 3 62 5 minus 2 4 7 90 2 86 2 0 0 8 62 6 55 7 minus 1 1. Total 0 12. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1 is equal to 1 minus 6 into 12 divided by 8 into 64 minus 1 is equal to 1 minus 72 divided by 504 is equal to 1 minus 0.1429 is equal to 0.8571. Therefore, R equals to 0.86. The value of R is close to 1, so it can be said that there is a high degree of positive correlation between the ranks obtained from the marks of statistics and accountancy. That is, if a student is having more or less marks in statistics, then his marks in accountancy are also more or less. This may not always happen for each student. Tie in observations, that is, when observations are equal. When values of some observations of variable x or y or both the equal, then a problem arises of assigning ranks to such observations. When values of observations of x or y are equal, we say that it is a tie. In such a case, average, that is mean of corresponding ranks, is assigned as rank to each of the repeated observation in the tie, and the next observation will get the rank next to the last rank used in calculating the average rank. Let us understand it by taking one example. Suppose observation for one of the variables are 37, 60, 42, 78, 42, 50, 66, 42 and 60. The highest observation is 78, so we assign rank 1 to it. Next are 66, so we assign rank 2 to it. Now, the next observation is 60, which are repeated 2 times. So the average of corresponding rank, that is third and fourth, which is 3 plus 2 divided by 2 is equal to 3.5, is assigned as the rank to each such observation, that is 60. Now, the next observation is 50. Since third and fourth ranks are already used, we will assign rank 5 to it. Now the next observation is 42 and it is repeated 3 times. So the average of corresponding ranks, that is 6th, 7th, 8th, which is 6 plus 7 plus 8 divided by 3 is equal to 7, is assigned as the rank to each such observation, that is 42. Finally, the last observation is 37. So, we assign rank 9 to it as the ranks 6, 7 and 8 are already used. In the same manner, ranks are also given to all observations of other variable. Now, when a tie occurs, some observations are equal. Correction is necessary in the formula of rank correlation coefficient. This correction is to be done by correction factor, that is CF. To obtain CF, we add the factor m cube minus m divided by 12 to sigma d square for each repeated observation group, where m is equal to number of times an observation is repeated. CF is nothing but the sum of the terms m cube minus m divided by 12 obtained for such repeated observation groups, that is CF is equal to sigma m cube minus m divided by 12. So for tied ranks, when some observations are equal, the formula for obtaining rank correlation can be written as follows. R is equal to 1 minus 6 sigma d square plus CF divided by n into n square minus 1, where correction factor, that is CF, is equal to sigma m cube minus m divided by 12 and m is equal to number of times an observation is repeated. Illustration 15. To know the relation between understanding of students in the subject of economics and their dancing skill, a sample of 8 students is taken and a test is conducted for them. The marks obtained are given below. Find the rank correlation coefficient between the marks obtained in two subjects. Marks in economics, marks in dancing skill: 60, 80, 30, 20, 10, 60, 20, 40, 30, 12, 50, 28, 30, 20, 40, 15. Answer. If we assign ranks according to the marks in economics, then the highest marks are 60. So, its rank is first, rank 2 for the marks 50 and rank 3 for the marks 40. Now, the next is marks 30, which are repeated 3 times. So, the average rank of the corresponding ranks, that is rank 4, rank 5 and rank 6, that is at 4 plus 5 plus 6 divided by 3 is equal to 5, will be the rank for the marks 30. Now, after mark 30, it is marks 20. So, its rank will be 7 and finally for the lowest marks 10, its ranks will be 8. Similarly, if we assign ranks according to the marks in dancing skill, then the highest marks is 80. So, its ranks will be 1, rank 2 for marks 60, rank 3 for marks 40 and rank 4 for marks 28. Now marks 20 are repeated 2 times. So the average rank of the corresponding ranks, that is rank 5, rank 6, that is 5 plus 6 divided by 2 is equal to 5.5, will be the rank for the marks 20. Now next are marks 15. So its ranks will be 7 and finally the lowest marks 12 will have rank 8. Now let us prepare a table as follows. Marks in economics X. Rank of X Rx. Marks in dancing skill Y. Rank of Y Ry. D is equal to Rx minus Ry. D square. 60, 1, 80, 1, 0, 0, 30, 5, 20, 5.5, minus 0.5, 0.25, 10, 8, 60, 2, 6, 36, 20, 7, 40, 3, 4, 16, 30, 5, 12, 8, minus 3, 9, 50, 2, 28, 4, minus 2, 4, 30, 5, 20, 5.5, minus 0.5, 0.25, 40, 3, 15, 7, minus 4, 16. Total 0, 81.5. The calculation of correction factor, that is CF, is as follows. Repeated number of observation times the observation is repeated, m. Sigma m cube minus m divided by 12. 30, 3 cube minus 3 divided by 12 is equal to 2. 20, 2 cube minus 3 divided by 12 is equal to 0.5. CF is equal to 2.5. R is equal to 1 minus 6 sigma d square plus CF divided by n into n square minus 1 is equal to 1 minus 6 into 81.5 plus 2.5 divided by 8 in bracket 64 minus 1 is equal to 1 minus 6 into 84 divided by 504 is equal to 1 minus 504 divided by 504 is equal to 1 minus 1 is equal to 0. Here R is equal to 0. So it can be said that there is a lack of linear correlation between the ranks of the marks in both the subjects. That is, the performances of the students of the given group in the subjects of economics and dancing skill are independent with reference to the linear relationship. Illustration 16. Two interviewers gave the following scores to the candidates on the basis of their performance in their interview. Find the rank correlation coefficient between the evaluations of two interviewers. Candidate: marks by first interviewer, marks by second interviewer. A 28, 32, B 44, 45, C 10, 25, D 28, 32, E 47, 41, F 35, 32, G 19, 24, H 40, 38. Here n is equal to 8. X is marks by first interviewer and Y is marks by second interviewer. Variable X is Rx and variable Y is Ry. Candidate: marks by first interviewer X, marks by second interviewer Y. Rank of X Rx, rank of Y Ry. D is equal to Rx minus Ry. D square. A 28, 32, 5.5, 5, 0.5, 0.25. B 44, 45, 2, 1, 1, 1.00. C 10, 25, 8, 7, 1, 1.00. D 28, 32, 5.5, 5, 0.5, 0.25. E 47, 41, 1, 2, minus 1, 1.00. F 35, 32, 4, 5, minus 1, 1.00. G 19, 24, 7, 8, minus 1, 1.00. H 40, 38, 3, 3, 0, 0.00. Total n is equal to 8. Sigma d is equal to 0. Sigma d square is equal to 5.50. Here, observation of variable x28 is repeated twice and observation of variable y is repeated thrice. So we prepare the following table to compute the rank correlation coefficient. The calculation of correction factor, that is CF, is as follows. Repeated number of variable times the variable is repeated m. Sigma m cube minus m divided by 12. X is equal to 28. 2 cube minus 2 divided by 12 is equal to 0.5. Y is equal to 32. 3 cube minus 3 divided by 12 is equal to 2.0. Total CF is equal to sigma m cube minus m divided by 12 is equal to 2.5. R is equal to 1 minus 6 sigma d square plus CF divided by n into n square minus 1. N is equal to 8. Sigma d square is equal to 5.50. CF is equal to 2.5. R is equal to 1 minus 6 into 5.50 plus 2.50 divided by 8 into 8 square minus 1 is equal to 1 minus 6 into 8 divided by 8 into 64 minus 1 is equal to 1 minus 48 divided by 504 is equal to 1 minus 0.10 is equal to 0.90. Illustration 17. A transport company wants to know the relation between driving experience and the number of accidents by the drivers. The sum of squares of differences in the ranks given to driving experience and the number of accidents by 8 drivers is found to be 126. Find the rank correlation coefficient. Answer. Here n is equal to 8 and the sum of squares of difference in the ranks is 126. That is, sigma d squared is equal to 126. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1 is equal to 1 minus 6 into 126 divided by 8 into 64 minus 1 is equal to 1 minus 756 divided by 504 is equal to 1 minus 1.5 is equal to minus 0.5. Illustration 18. 10 students selected from various schools of a district were ranked on the basis of their proficiency in sports and general knowledge. The rank correlation coefficient obtained from the data was found to be 0.2. Later on, it was noticed that the difference in the ranks of the two attributes for one of the students was taken as 3 instead of 2. Find the correct value of rank correlation coefficient. Here n is equal to 10. Incorrect d is equal to 3. Correct d is equal to 2. Now r is equal to 1 minus 6 sigma d square divided by n into n square minus 1. 0.2 is equal to 1 minus 6 sigma d square divided by 10 into 100 minus 1. 0.2 is equal to 1 minus 6 sigma d square divided by 990. 6 sigma d square divided by 990 is equal to 1 minus 0.2. 6 sigma d square divided by 990 is equal to 0.8. Sigma d square is equal to 0.8 into 990 divided by 6. Sigma d square is equal to 132. Since one difference 2 is wrongly taken as 3, the corrected value of sigma d square is obtained as follows. Corrected sigma d square is equal to 132 minus wrong d whole square plus correct d whole square is equal to 132 minus 2 square plus 2 square is equal to 132 minus 9 plus 4 is equal to 127. Correct value of the rank correlation coefficient is obtained as follows. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1 is equal to 1 minus 6 into 127 divided by 10 into 100 minus 1 is equal to 1 minus 762 divided by 990 is equal to 1 minus 0.7697 is equal to 0.2303. Therefore, R equals to 0.23. Merits and limitations of Spearman's rank correlation method. Merits. 1. This method is easy to understand. 2. The calculation of rank correlation method is easier than that of Karl Pearson's correlation coefficient. 3. It is the only method when the data is qualitative. 4. When dispersion is more or when the extreme observations are present in the data, Spearman's formula is preferred over Karl Pearson's formula. Limitations. 1. Since the ranks are used instead of the actual observations, there is always a loss of some information. So this method does not provide accurate value of the correlation coefficient as compared to Karl Pearson's method. 2. unless the ranks are given. It is tedious to assign ranks when the number of observations is large. 3. This method cannot be used for a bivariate frequency distribution. In such a case, Karl Pearson's method is used and you will learn it in your higher studies. Illustration 19. Determine the value of the correlation coefficient from the following results. Covariance xy is to sx square is equal to 3 is to 5 and sx is to sy is equal to 1 is to 2. Here, covariance xy is to sx square is equal to 3 is to 5. Therefore, covariance xy divided by sx square is equal to 3 divided by 5. And sx is to sy is equal to 1 is to 2. Therefore, sx divided by sy is equal to 1 divided by 2. Now, R is equal to covariance xy divided by sx into sy is equal to covariance xy divided by sx square into sx divided by sy is equal to 3 divided by 5 into 1 divided by 2 is equal to 3 divided by 10. Therefore, R is equal to 0.3. Illustration 20. The following results are obtained from a bivariate data. N is equal to 10, sigma x minus x bar into y minus y bar is equal to 72. Sx is equal to 3 and sigma y minus y bar whole square is equal to 160. Find the correlation coefficient. From the available results, first we shall find Sy. Sy is equal to under root sigma y minus y bar whole square divided by n is equal to under root 160 divided by 10 is equal to under root 16 is equal to 4. Now, substituting the necessary values in the following formula. R is equal to sigma x minus x bar into y minus y bar divided by n into Sx into Sy is equal to 72 divided by 10 into 3 into 4 is equal to 72 divided by 120. Therefore, R is equal to 0.6. Illustration 21. An educationalist has conducted an experiment to know the relation between the uses of social media in mobile phone and the result of the examination. A group of 10 students is selected for this end. The following results were obtained regardingly. The time spent X in hours in last week on social media and the marks Y obtained out of 50 in the examination taken it immediately after it. Sigma X is equal to 133. Sigma Y is equal to 220. Sigma X square is equal to 2344. Sigma Y square is equal to 6500 and sigma xy is equal to 3500. Later on, it was found that one of the pairs of observations of x and y was taken as 13, 20 instead of 15, 25. Find the correct value of the correlation coefficient between x and y. Answer. Here n is equal to 10, sigma x is equal to 133, sigma y is equal to 220, sigma x square is equal to 2344, sigma y square is equal to 6500 and sigma xy is equal to 3500. Incorrect pair 13, 20. Correct pair 15, 25. Now we find corrected values of these measures as follows. Sigma x is equal to 133 minus 13 plus 15 is equal to 135. Sigma y is equal to 220 minus 20 plus 25 is equal to 225. Sigma x square is equal to 2344 minus 13 square plus 15 square is equal to 2344 minus 169 plus 225 is equal to 2400. Sigma y square is equal to 6500 minus 20 square plus 25 square is equal to 6500 minus 400 plus 625 is equal to 6725. Sigma xy is equal to 3500 minus in bracket 13 into 20 plus in bracket 15 into 25 is equal to 3500 minus 260 plus 375 is equal to 3615. Substituting these corrected values in the following formula, R is equal to n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square is equal to 10 into 3615 minus 135 into 225 divided by sigma 10 into 2400 minus 135 square into under root 10 into 6725 minus 225 square is equal to 36150 minus 30375 divided by under root 24,000 minus 18,225 into under root 67,250 minus 50,625 is equal to 5,775 divided by under root 5,575 into under root 16,625 is equal to 5,775 divided by under root 9,60,09,375 is equal to 5,775 divided by 9,798.4374 is equal to 0.5894. Therefore, R equals to 0.59. Illustration 22. 1. If the correlation coefficient between two variables x and y is 0.5, find the value of the following. Number 1. R x minus y. Number 2. R minus x y. Number 3. R minus x minus y. Here R xy is equal to 0.5 from the property number 5 of correlation coefficient. Number 1. R x minus y is equal to minus R xy is equal to minus 0.5. Number 2. R minus xy is equal to minus R xy is equal to minus 0.5. Number 3. R minus x minus y is equal to R xy is equal to 0.5. 2. If R xy is equal to 0.8, then find R uv for the following. Number 1. U is equal to x minus 10 and v is equal to y plus 10. Number 2. U is equal to x minus 5 divided by 3 and v is equal to 2y plus 7. Number 3. U is equal to 2x minus 3 divided by 10 and v is equal to 10 minus y divided by 100. 4. U is equal to 5 minus x divided by 2 and v is equal to 5 plus y divided by 2. 5. U is equal to 20 minus x divided by 3 and v is equal to 20 minus y divided by 7. Here R xy is equal to 0.8. While defining u and v from the properties number 4 and number 5, the value of R uv will be dependent on the signs of the coefficients of x and y. Number 1. R x minus 10 y plus 10 is equal to R uv is equal to 0.8. Number 2. R x minus y divided by 3 2y plus 7 is equal to R uv is equal to 0.8. Number 3. R 2x minus 3 divided by 10 minus y divided by 100 is equal to R uv is equal to minus 0.8. Number 4. R 5 minus x divided by 2 5 plus y divided by 2 is equal to R uv is equal to minus 0.8. Number 5. are 20 minus x divided by 3, 20 minus y divided by 7 is equal to our UV is equal to 0.8. Illustration 23. A project is conducted by the group of the students of an MBA institution to know the relation between the results of the final year of school and final year of graduation for the students. The following information is obtained from a sample of 10 students regarding the percentage of marks in Standard 12 X and the percentage of marks in the final year of graduation Y. N is equal to 10, sigma x minus 65 is equal to minus 2, sigma y minus 60 is equal to 2, sigma x minus 65 whole square is equal to 176, sigma y minus 60 whole square is equal to 140, sigma x minus 65 into y minus 60 is equal to 141. Find the correlation coefficient between the percentages of marks in Standard 12 and the final year of graduation. Here, sigma x minus 65 is equal to minus 2 is not equal to 0. Therefore, A is equal to 65. Sigma y minus 60 is equal to 2 is not equal to 0. Therefore, B is equal to 60. Here the sum of deviations are not 0. So 65 is not equal to x bar and 60 is not equal to y bar. Now let us define u is equal to x minus 65 and v is equal to y minus 60. So sigma x minus 65 is equal to sigma u is equal to minus 2. Sigma y minus 60 is equal to sigma v is equal to 2. Sigma x minus 65 whole square is equal to sigma u square is equal to 176. Sigma y minus 60 whole square is equal to sigma y square is equal to 140. Sigma x minus 65 into y minus 60 is equal to sigma uv is equal to 141. Substituting the above values in the following formula. R is equal to n sigma uv minus sigma u into sigma v divided by under root n sigma u square minus sigma u whole square into under root n sigma v square minus sigma v whole square is equal to 10 into 141 minus in bracket minus 2 into 2 divided by under root 10 into 176 minus in bracket minus 2 square into under root 10 into 140 minus 2 square is equal to 1414 divided by under root 1756 into under root 1396 is equal to 1414 divided by under root 24,51,376 is equal to 1414 divided by 1565.6871 is equal to 0.9031. Therefore, R equals to 0.90. Illustration 24. To study the relation between the age X years of teenage children and their daily requirement of protein Y grams, the following information is obtained from a sample of 10 children taken by the Health Department of State. Sigma X is equal to 140. Sigma Y is equal to 150. Sigma X minus 10 whole square is equal to 180. Sigma Y minus Y bar whole square is equal to 215. And sigma X minus 10 into Y minus 15 is equal to 60. Find the correlation coefficient between X and Y. Here X bar is equal to sigma X divided by N is equal to 140 divided by 10 is equal to 14. And Y bar is equal to sigma Y divided by N is equal to 150 divided by 10 is equal to 15. We can see that the deviations are not taken from actual mean. X bar is equal to 14 for the variable X. So, to solve the example, it will be convenient to define U is equal to X minus A is equal to X minus 10 and V is equal to Y minus B is equal to Y minus 15. We are given the following information. sigma x minus 10 whole square is equal to sigma u square is equal to 180. Sigma y minus 15 whole square is equal to sigma v square is equal to 215. Sigma x minus 10 into y minus 15 is equal to sigma uv is equal to 60. Now, in order to use an appropriate formula of R, first we need sigma u and sigma v. Sigma u is equal to sigma x minus 10 is equal to sigma x minus sigma 10 is equal to sigma x minus n into 10 is equal to 140 minus 10 into 10 is equal to 140 minus 100 is equal to 40. Sigma v is equal to sigma y minus 15 is equal to sigma y minus sigma 15 is equal to sigma y minus n into 15 is equal to 150 minus 10 into 15 is equal to 150 minus 150 is equal to 0. Therefore, sigma k is equal to k plus k plus k plus up to plus k is equal to nk, where k is equal to constant n times. Substituting the above values in the following formula, R is equal to n sigma uv minus sigma u into sigma v divided by under root n sigma u square minus sigma u whole square into under root n sigma v square minus sigma v whole square is equal to 10 into 60 minus 40 into 0 divided by under root 10 into 180 minus 40 square into under root 10 into 215 minus 0 square is equal to 600 minus 0 divided by under root 1800 minus 1600 into under root 2150 minus 0 is equal to 600 divided by under root 200 into under root 2150 is equal to 600 under root 4,30,000 is equal to 600 divided by 655.7439 is equal to 0.9150. Therefore, R equals to 0.92. Illustration 25. To know the relation between the ability in two different subjects for the students, a sample of 7 students is taken from a school. From the information of marks in two subjects for 7 students, it is known that the sum of the squares of differences in the ranks of these marks is 25.5. It is also known that 2 students got equal marks in one subject and all the remaining marks are different. Find the rank correlation coefficient. Here n is equal to 7 and sigma d square is equal to 25.5. 2 students got equal marks in a subject. Therefore, m is equal to 2. So we can say that there is a tie in assigning the ranks. Therefore, we need to take the term m cube minus m divided by 12 only once to obtain CF. CF is equal to m cube minus m divided by 12 is equal to 2 cube minus 2 divided by 12 is equal to 0.5. R is equal to 1 minus 6 sigma d square plus CF divided by n into n square minus 1 is equal to 1 minus 6 into 25.5 plus 0.5 divided by 7 into 49 minus 1 is equal to 1 minus 6 into 26 divided by 336 is equal to 1 minus 156 divided by 336 is equal to 1 minus 0.4643 is equal to 0.5357. Therefore, R equals to 0.54. List of formula. Karl Pearson's method. 1. Correlation coefficient is equal to R is equal to covariance xy divided by sx sy is equal to covariance xy divided by standard deviation of x into standard deviation of y, where covariance xy is equal to sigma x minus x bar into y minus y bar divided by n is equal to sigma xy minus n x bar y bar divided by n. A. Sx is equal to under root sigma x minus x bar whole square divided by n, and B. Sy is equal to under root sigma y minus y bar whole square divided by n. 2. R is equal to sigma x minus x bar into y minus y bar divided by under root x minus x bar whole square into under root sigma y minus y bar whole square. 3. R is equal to n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square. 4. R is equal to n sigma uv minus sigma u into sigma v divided by under root n sigma u square minus sigma u whole square into under root n sigma v square minus sigma v whole square. 5. R is equal to sigma x minus x bar into y minus y bar divided by n into sx into sy. 6. R is equal to sigma xy minus n x bar y bar divided by n into sx into sy. Spearman's rank correlation method. 7. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1 when the observations are not repeated. 8. R is equal to 1 minus 6 sigma d square plus cf divided by n into n square minus 1 when some of the observations are repeated, where d is equal to rank of x minus rank of y is equal to rx minus ry. Cf is equal to correction factor is equal to sigma m cube minus m divided by 12. M is equal to number of times an observation